Hello grade 10. Now we move to the lesson 3, metals and non-metals. As you can see, this is the Mendeleev periodic table. Here periodic arrangement of the elements. Elements are arranged periodically. Okay, they are arranged in their according to the increasing atomic number. See, here is two series are there. This is your left hand side. These are metals. Here is your right hand side. Correct? Here is your non-metals, and in between series they are called metalloids. Another name is transition metals. It means they behave like metals as well as non-metals. Clear? These are two rows which we have taken from here, so that's why they are called as inner transition series, because we have taken from inside the transition series. So this is the table. Now we move to the physical properties of the metals and non-metal. As you can see here, metals tend to lose their valence electrons. So what do you mean by valence electrons, students? Suppose here is your atomic structure they have given. In the center nucleus is there, capital N. It consists neutron plus proton. Clear? Neutron, the charge of neutron is 0 and the charge of proton is positive. Whatever you are taking in a positive and you are adding with any digit, like you are adding 10 plus 0, so automatically you are getting the 10, means the positive one value. So due to the presence of protons, which is having the positive charge, the nucleus is a positively charged fundamental particle. Here are the shells. We can add one more also. So these shells are named as K, L, M and so on. These are shells, right? In a first shell we have 2 electrons here, 8 and 8. So these are the rules according to which we fill the electrons. 2 electrons, like 1 electron is here, second electron is here, another 8 electrons are there. So this is the atomic structure. Okay, if you talk about hydrogen, its atomic number is 1. So how we fill the electron? In the center nucleus is there, in a outermost shell 1 electron is there. It means to complete its duplet rule. 2 means duplet rule and 8 means octet rule. Atom follow these two rules, it obeys these rules. Okay, so hydrogen, it's according to the atomic number, it is having only 1 electron. It needs one more, either it lose or gain, right? So it actually lose also and gain also, it shares. We talk about lithium, its atomic number is 3. So in outermost shell, how many electrons will be there? In the center nucleus is there 1, 2. It means we cannot fill 3 electrons in first shell, because according to the rule we can fill only 2 electrons. So the another one will be shifted to the another shell. Now there is a lack of 7 electrons. Minimum gain or lose of electron is called valency. Means outermost shell is acting as valence shell, from where we are taking the electrons either in or out. This valence shell is having 1 electron, so it is easy to remove this 1 electron instead of taking 7 electrons. In chemistry we are writing minus, it means we gain the electrons, and if we are using plus sign, it means it lose the electron. So lithium is showing plus 1 valency, so we are writing like this. So this is metal. Lithium is the heaviest metal. One of the examples, L small I, right? Plus, we are adding plus, means it's plus 1. Correct? So move to metals. Metals tend to lose their valence shell, valence electrons, and non-metals, they share either gain the valence electrons. Clear? I think first point is clear to you. Second is good conductor of heat and electricity, because they have free electrons. You know that they are good conductors, but because of what reason they are good conductors? Because they are having the free electrons. See, they are free. They are neither combined with any other atom. So they are freely existing, so they conduct electricity. It is bad conductor because either they are have filled or fully filled. Correct? High melting point, boiling point, it is having low melting point and boiling point. They are lustrous, they are very shining like diamond, and they are non-lustrous. Clear? So they are malleable. They are drawn into the sheets, but they cannot drawn into the sheets, so they are non-malleable. It shows the property of ductility, means that sheets can be beaten up into the thin wires that we are using in our daily lives. Correct? In electricity we are using. So they are showing the property of ductility, and they are non-ductiles. They are sonorous. They are producing sound, striking. Have you heard the sound? So this is sonorous, right? And they are non-sonorous. Here the exceptional case is mercury. Their symbol is H small g. H is capital and small g. We are using in a thermometers. Correct? And there is a exceptional case bromine. B capital and R is small. The similarity is both are existing in a liquid state. There are 78% metals, and here is 22% metals, out of which 10 are solid, 11 are liquid, and 11 are gaseous, and 1 is on a liquid state that we have taken as a exceptional case. Clear? Total 22 is there. 10 solid, 11 gases, and 1 liquid. Correct? They are existing in a liquid state. So carbon is a one element which are having different allotropes: diamond, graphite. Diamond is an exceptional case in the case of metals. How? Which property resemble with the diamond? Say here is a lustrous. Diamond is lustrous. So it bears the same properties here like this. So they are lustrous, and they are under metals. If we talk about the bad conductor of heat and electricity, right? So graphite, another we use the substance in gray, like in that made up from carbon. So they are considered in a non-metals because they are the bad conductors of electricity. Likewise, there are so many exceptional cases in metals and non-metals. You just go through the chapter once and read thoroughly. Stay tuned. Bye bye.